Hey guys, welcome back. In this section, we're going to look at models for dealing with inputs that rely on the sequence in which the data appears. Let's take a look at the outline for this section. First video, we'll introduce the problem of text classification. We'll look at why that poses a problem. Second video, we'll look at the problem of representing text data in numeric format. There are two approaches to this, encodings and embeddings. Third video, we'll look at the problem of extracting patterns from text data, such that we're able to place the text into different classes. We'll be doing that using recurrent neural networks. In the fourth, we'll look at the same problem, but this time around, we'll make use of convolutional neural networks. In the fifth and final video, we'll look at the other types of convolutions that could be applied to the problem of text classification. But before we get started, let's review one possible solution to our assignment. If you have not done that, you could pause the video and go and take a look at the assignment, then come back when you're done. Do go through the code, and then join us for the rest of the module. So what's the problem exactly with text? On the screen, we have two sentences. The first one says, lions eat goats. The second one says, goats eat lions. Now ignore the truth behind the sentences. And what you find to be the difference between the two sentences is essentially the sequence of the words. So both sentences contain the same words, but the sequence is what gives meaning to the sentences. So given that, we start to ask ourselves, what's the problem when it comes to dealing with text? How is text different from image data, for example? Well, first thing you need to worry about is what's called semantics. And there are two types of semantics when it comes to text. First is called logical semantics. That refers to the sense and the reference and the implications of the text. We saw that previously. The second type is called lexical semantics. That deals with an analysis of word meanings and relationships between them. Another problem is that of numerical representation. It's important to always bear in mind that computers always deal with numbers, so whatever it is that we're going to be feeding as data to how models must have a numerical representation. Another problem we must deal with is that of what tokenization and parsing. Word tokenization is dependent on the language under consideration. In languages such as English, words are separated by space. But that's not the case in every language, so languages put words together to give them meaning. But then without a thorough understanding of that language, it's impossible to tell where one ends and the next begins. Another problem with text data is that of non-standard language. The standard language is what you would find if you were to pick up any dictionary for that particular language. But non-standard language includes things such as spelling words wrongly, or leaving some things out, such as punctuation, apostrophes, hyphenation, or shortening words. A very good example of non-standard language is what you would find on Twitter, where people try to either shorten words or replace sets in phonetic sounds with numbers, so that they can fit a lot of data into the character limits of the platform. There's also the problem of segmentation, and with segmentation, the question is essentially what group of words belong together. If you're looking at a body of text, is there a subject and is there an object? Is a subject one word or a group of words? Is the object one or a group of words? If there's hyphenation, do you take it as one group or do you break it apart? So segmentation is also an important consideration. There's also the problem of idiomatic expressions. While the words taken on their own might have a different meaning, idiomatic expressions need to be put together, which is again the problem of segmentation. Then they have a completely different meaning. So what do you need to know to deal with text problems or language problems? First off, you need to know the language. You need to have a thorough understanding of that language, which again goes back to the topic of domain expertise. If you do not have a thorough knowledge of the language, then you're going to need to have some resources on your team. Whose domain of expertise is that language? You also need to understand how the language is used. That's the world context of the language. You need some knowledge of text processing, because the text needs to be converted into a numerical representation. And you need to know how to find the root words for any words that appear in the text. There's also the issue of temporal classification. Recall what we said, sequence is very important, so you'll need to know how to handle sequence data. Then finally, there's probabilistic models and probability factors, because you're dealing with sequences. You need to be able to compute the probability that one word appears in this sequence after another. We're going to see examples of text processing when we start to write code, but some of the things to bear in mind: the word tokenization, a bag of words as ways of converting your text data to numerical representations,